Hi, I'm Dimitri,
Hi, I'm Uberto.
and in this video we're gonna finish Game of 4 game.
Yeah, let's
Connect
try
four, right,
Connect
yeah.
for at least we wanted to arrive at determine who is the winner, or if there is a winner and who is the winner for each position.
Yeah, cool.
Yeah. Then maybe in the future we also do the solver. But
Yeah, so should we then do similar thing as the last time, have some
Yes.
to-do list? So what's the first thing we want to do?
I think we left the last time that we wanted maybe to create a kind of abstraction for the pile to represent the pile of
Pile class.
yeah on chips basically.
Yeah, cool.
And then we wanted to, well, at the end, what we really want is to determine who's the winner,
yeah.
and then stop the play, basically.
Yeah. So yeah, with the pile. Let me just run the thing.
Yeah, I think
first, just to remind
yes.
ourselves what it's doing.
Well, yes.
Yeah, and I think this is the area with the pile.
Yeah, exactly. That this was a bit of a smiley.
So what we had, we had a bunch of moves, these moves, and they end up with this.
Yeah, with
boards.
yes.
Yeah, and we had a pile here.
Yes, exactly. The idea was to put this basically the wall things in an object. So instead of filtering the moves, we can.
So pile is this vertical thing.
Yes.
It's like a column,
And
a stack of things. Yeah, pile.
So each column will have one pile basically, and the pile will be a list of.
So just data class pile.
Yeah.
And then
it will for sure will be associated to a column, but I'm not sure if we need. I'm not sure if the pile should know about its column or not.
So it will be a bunch of moves then.
And then yes, and then a bunch of moves.
So it will be about moves.
So what is in moves now? Let's do a bit fresh.
It's just this thing, right? It's a data class of
Yeah.
player and column.
So actually, we just needed the player. We don't because the column will be the same for each.
Okay. So yeah, but then
Yeah,
you
I
know
mean,
what you want to.
no, just that it's just a player.
Oh, okay. Yeah.
So we like to write something like basically if they say that we have for each pile, let's say, and then
pile has
yes, as what we can call what a chip or player. Player, for example, and then passing the hole, and then probably at this point we can just. Actually, this will be our method. So
okay, I'm not sure what you mean, but yeah.
No, I mean just like okay. So if these are the, let's say, piles, list of pile. We can say
Piles and for each,
and then or
like
map.
Join, yeah, we need to map, and then for each pile we'll figure out if there is a current row. Yeah,
something like this, and then we wanted to join to string, so we can do join to string.
Oh yeah, I see. Yeah, I see what you mean. I think.
Yeah,
we could do join to string after piles.
Yeah, or just to keep it something like
that. Yeah, I think what she meant is that. Oops. Sorry. So we can do join to string here basically. It will be join to string with an empty. Right. And then player will return one of those signs, basically this. Right. That's what we want.
Exactly.
This will be on a pile, so we could move it into the pile, this whole code. So can I just do player create member function,
Yes.
something like that?
And there will be a sign probably as a return.
Yeah, so that's roughly what we want, and that's row char is.
Yeah,
Oh,
just return.
yeah, we need to.
We need
I
to.
did the wrong join to string, I suppose. We need all of those, right?
Yeah.
Basically, we need
Yes.
all of that. Okay. No, that makes sense to me. So if I format, and then we can just return that, I guess.
Yes.
And delete all of that.
Yeah, and then get rid of the return. So it's.
Oh yeah. Well, we still haven't done the actual thing.
Yeah.
Right.
And then.
Can maybe remove moves. But then it's still red here because we don't really pass in piles.
Yes. Of course.
No, the hard part for you.
Okay. This is show. So
It has all the moves, but
I think this will be
yes.
pies. Yeah, done.
Yeah, that was easy.
That was easy. Yes. So
We could have a field right inside the board, so every time we update the board, it kind of creates piles.
yes, exactly. I was thinking something like rewrite.
So it's a mutable board.
Yes, since it's immutable every time we create.
We need to maybe map fold do something with moves, I suppose, right?
Yeah. We can retrieve from the moves. Yes.
Yeah, so we can somehow aggregate moves into piles.
Yes.
I'm not sure how, but.
Yeah, there is actually the group by. If
by column. And
yes.
that's a pile, basically. Yeah, group by each column. Yeah. Then
column,
it becomes a map. Basically, we want maybe to go through all columns like we did before.
Yeah, probably
values,
values.
Or
and
something
then,
like that.
Yeah, that will be map.
And there's a column here. Then we moves filter by columns. Column equals column. Then we end up with all the moves.
And then we need still the last map.
Oh yes, thank you. It just will be it. Something like that. No.
We need also to map somehow the layer.
Oh, it's the same. Okay, I'll put it back. It map. That thing.
Yes.
Okay. Hopefully now it's good. Yeah, that looks fine.
That's bad.
That was the problem. Cool. That's
okay.
So we did the refactoring.
Yes,
okay,
we did the
done
refactor.
with this thing.
Yes.
Then
Okay, and now we just need
find winner.
Yeah, to find the winner. Now, to find the winner, one thing that we can use is that we just needed to calculate the winner if the last position is creating a winner. So we are not looking at the
So
wall.
right now, what we're doing fold and we do board place.
Yes.
And when on place, we add moves and we want to, at some point, specify the winner. Maybe when we construct the board, we automatically find the winner. Is that what you meant?
I think when we create one possibility is when we create the moves, we can assume that the last move is the last move.
Yeah.
But the other possibility is when we place. Where is the place?
Yeah, place.
Place. We can here we can have some check basically in the board. And
in a way, I like that if the winner is part of the board.
Okay, so let's do when we create the board.
So because it fits with what we have right now, we always have player piles.
So I think we can start with something like Well, we said that the winner will be
A player.
a player
Or nullable.
or not. Yes, exactly. So that's will be.
Maybe start with null. Oh yeah, sorry.
And well, either we can do we can update this in the init or create a function. It's probably good enough to do a function.
Yeah, I don't mind. Yes, fundamentally there is no big difference. It's an immutable class, right?
Yeah.
It's just-
So the idea here is that we take the last. So for example, we can say if moves is empty.
Definitely no winner.
Yeah. We definitely
I
have
agree
no.
with that.
It's why is complaining just because of,
yeah, it just wants something to If we do that.
yeah.
We can even plug this in. It's just to plug into the main loop to print it out.
Yes.
Maybe that's the thing. Just to.
Okay, let's.
It's just as a small step. Just to.
Yes,
just take
we can put.
Should we have it at the end then?
Yeah, in the.
And this thing. Then maybe format it as a bit like that. Yeah, it doesn't matter really, so I'll just run it, see if it prints things.
Okay. Yes, which is wrong, but.
And maybe also this thing to make it look slightly nicer. So yeah, so that's like the simplest thing we can do.
We only printed the last one. Okay, sure.
Yeah, we don't print on every fold right now. Maybe we won't. Should
Well,
we do that then as well? Because right now I think we fold and then we just show, but we actually want to
actually,
show on every fold, right? Maybe that's what you meant.
Yeah, but actually I was. Okay, yeah, we can also do that.
So we'll just board.show.
Oh, well, maybe after the place.
We're doing it here.
Okay, yeah, you're right.
So,
yes.
Yeah, there is a bit of duplication. I'm not sure.
But no, but it kind of makes sense. Yes.
So now it starts printing, but there is no winner.
Okay. Yeah.
And
So the
that's
first
that.
and then it's node, which is.
It's a bit also confusing the way it's printed right now. So it's like there is no winner actually is about the first thing, and then it becomes not, which is just hard coded.
Yeah.
Yeah. Okay.
I think the easiest way, and that makes sense, is say if board.
Winner is not null, right? Oh, it's
Yeah,
not
it's
public,
it's
I
not
think.
public. Okay. But just say if it's not null, and then this is okay. For the
And
moment.
else it's a board basically, and then it will just keep folding, but it will ignore the rest. So
exactly.
it'll just come out. Else it's just board. And
Yeah.
then maybe even do like has a winner.
Okay, yeah, but probably.
Okay. It was just the if was wrong. That was the Okay.
Yeah.
So now moving on to the winner, I suppose, to make it something.
Yeah, a bit more smart.
Real. Yeah.
So for example, we can try to. The easiest way to get the winner is if the column, if you put the chips and all the chips under you are the same color. That means that you are winner. This is the simplest solution.
So because chips they always drop,
Yes.
you don't even need to go up really.
Yeah, exactly, because it cannot be. You cannot put
yeah.
something on top. That will be the simplest possible.
Yeah, just one, and that's exactly the example we have, right? Well, with our moves, I think it was exactly the case.
So we need to verify basically if there is something like, and the result will be a player number.
Oh, I see. So basically,
Just for this should, if I just return,
not, yeah.
this should work.
Okay. I'll just do formatting. Oops. Follow that. I do this. So that's the, if I just run it.
Okay, so for some reason, formatting is strange.
So yeah, it still works, right? So that
Yeah.
was kind of small refactoring.
Yeah. Pies or whatever, probably. This is but anyway, something ordinary, I think is.
It's lowercase column.
Yeah.
So basically, look at all the piles.
So here we take our pile.
Oh yeah, see, we want to get the pile for the current column.
Yes.
Basically, and then.
So we okay. Now we just needed to check that this pile must be at least 4, and the last. Or we can probably do starting from the last element of the pile. We go back and we check how many they have on the same column.
Yeah, see, like take while or something like
Yes,
that.
yes,
Yeah.
yes.
So piles also they.
Can you do take while on the reverse?
On what?
Going backwards?
Oh, we can always do reversed or something.
Yeah, yeah, of course.
But that's not an actual type right now, so it actually didn't work.
Yes, this is.
There is no piles, but
No, this should work.
No, because piles was just a list, right? We didn't make it into.
Yeah, but this is a list, and we are taking the X element of the list, so this should work. Why there is no?
Yeah, I'm not sure what happened. Why it's not highlighting anymore.
Okay.
Maybe we press some shortcut or something.
Yeah.
We can still try this thing, specify type. That's just a pile, so that actually works. Then you're saying we want moves, basically. Yeah. And then we want to take while.
Take last while.
Even, yeah, it's even better.
Yes.
We want to take last while it's equal to the last thing in the
yes.
pile.
Yes.
Well, I think one thing to do before we do this, if pile is empty, that's null, right, for sure.
If it's if it's
pile values. Oh, sorry, moves.
Moves is. We can even check that directly if it's less than 3. We are sure, but whatever. I mean.
Oh, I see, because it's check winner.
Yeah, I mean, it cannot be. It's 4.
Should I do that then?
But it's a bit little. But okay, this is it's okay. I mean, it's empty now. Yeah.
So take while, and then we have last move, or what should I call it?
Yeah. Current player.
Oh, player. Maybe just player.
Yeah.
And that will be moves.
Last. Dot player. Or sign.
Yeah.
No, sign is a card.
Oh, this is last player already.
Oh, okay.
I think.
Yeah, because actually it's called a moves,
Not
but
moves.
it's not a moves. Yeah.
Then take while it equals player. It
Yes.
will include the current move, so it will be all the moves.
Yeah,
and
but
then like dot count.
Yes.
Then equals then equals 4.
If return player.
If this, then we return player.
Yes.
Otherwise, it's null.
Yeah. Yeah, we don't need to return that, but
Should
it's
be
in the
here.
front of it. Yeah.
So yeah, that's actually good because it's like no winner. Right, so from the beginning it starts no winner. We do moves. Then it gets to the point when knots are winning at this point.
Okay, yeah,
and then
I know
it
it's
stops.
not. So we
looks okay for this case.
I think this is correct.
Yeah.
For the vertical check.
Yeah, but now if we want to generalize, there will be also a horizontal check.
Yes.
And diagonals.
Yes,
well.
and two diagonals. But I think we probably want at this point to think about having the something that say player at position, and then if we refactor this code, in a way that say using player at position instead of specifically the pile, then we can generalize for other shape. I mean, horizontal or diagonal. Yeah. So basically, what we want to do?
If you want.
I think if we extract something like private
fun, private fun.
Find player.
Fun. I mean, as a function.
No, sorry.
Player.
Player at position. Okay, now that I'm thinking, position will be something column, but column plus
Row.
row. But that's okay. I mean, it will be something like. Okay, for the moment this is enough. So player position, and we still have the same player.
Player or nothing. If
Yes.
there is nothing.
There is no player position.
Good.
And at this point we can say we can have some check first, probably like if position column, then there is a ordinal. Well, no, it should be because it's an enum, so it should be correct. We don't have it to go -1. I mean. We only needed to check that basically.
So rows, they can be thing that we don't have. So columns for any columns are guaranteed to be correct because it's an enum. Right?
Yes, and
rows might not be if we don't have. Let's say like the whole thing is empty.
Yeah, exactly.
Then
but
we
that
have no rows. So.
We just needed to check if the pile for the column
contains the.
Yes, moves what is called players. Actually, we can see if it's a length size basically is bigger or equal to the position row. Ordinal. So let's have a check. So if the row is 0 and the sides is 0, this is not okay. So it must be strictly bigger.
Less than size. So what we're doing, we're taking the current pile for the column and seeing if there are enough rows, basically, for the current position.
Yeah, so basically doing this one.
So that's the current pile.
Yes.
Yeah, so if it's bigger, then we can do something.
Something like that. Okay, let's do elect. So this will be. Yeah. Actually, since there's any run would be better. So we can have a.
So, okay.
Player side, sorry. So, in this case, we can just return the players with the position. Position.
Dot ordinal, I think.
Yes.
Yeah, otherwise it's null.
Yeah.
Definitely want this player position, and we want to position somehow.
Yeah.
And position, so we want position.
Yes.
And position will be something there.
Actually, it would be pile dot size or something like that.
Oh.
Yeah.
So
okay.
It takes a column.
Column is column.
Yeah. So we have column. I'm doing just like with types. I don't think too far. So then row will be the last move.
No, we can take a pile. We already have.
Oh, we have pile, and the last player will.
Be player size or something like that.
Oh, but that has to be a row. So
Yes.
we need to row value of something, values, and
Yes.
then look up by that.
Yes.
-1.
-1. Yeah.
Because sizes.
Yeah.
Okay.
Okay, we can put this stuff
Yeah,
in.
I think this is already a thing to try. So this works at least.
Okay,
Like doesn't
yes.
crash with the array index out of bound or anything.
Exactly.
So yeah, then can plug it in. So we want to take a player at position. So now
Yeah.
we can have like start moving position. That's what.
Yeah.
So if we do 4 or whatever.
Well, let's start with the 4. That is simple.
0 or 4 or 0 until something.
Okay.
We can do 4. Is that
Well,
good?
actually, it would be. We have the current position. So we wanted to.
Do like next or something like down.
I mean, we want to start from the current position and say, okay, we can have let's define a function that goes south.
Mm-hmm. So it will be
Position dot south.
Something like that.
Yes, and
South, and it returns a position.
position. Yes, and there will probably need to be a nullable position.
Or should it just return the same position?
Or return the same.
I don't know. Would we
No, but if you return the same, mean that if you are
Okay.
nullable is
Yeah,
probably
okay.
better.
Yeah, okay. Let's make it then explicit. Just south. So it's this. So we're saying there must be some if then.
Yeah, so I suppose there
So
will
if
be.
row is the last row, basically.
Is
then we-
0, so yes.
But if we go south, oh, that's 0. Yeah.
Yeah,
Well,
so south.
Also, it's
south.
interesting. We have row dot a.
Yeah.
One that maybe it's null.
Yeah, it's better. Yes.
If row equals dot and then it's null, otherwise we move on somehow.
Yes.
So it will be artifacts. Otherwise it's position. We could do a copy really, right? And column is the same, row we're gonna be next row. So I'll do it the same funny way. Row values. Oops.
Yeah, we need to also probably
Values
to
and
put.
then row ordinal. This is not nice. I'm not saying
No.
it's, it's also,
At least we should have a factor, but
yeah. It's an interesting thing. Like there are benefits of having enums, but maybe just pure data class is also nice.
yeah, because I mean, it would be nicer to say a whole next
It's
and
actually not plus, it's -1, right? So we get current row.
yes,
And yeah.
because
South.
I suppose the R1 will be with the 0 or the none. Yeah, it's the first one. So
Yeah, the column side, this is going to be like
Yeah.
0 inside.
Yeah.
So I'll run this and we'll see if south works,
Because-
I suppose. We just plugged in.
Kotlin enum doesn't have a prev and the next.
I think it still works. We just plugged in a bunch of expressions. They don't have any side effects, so it's safe. And then
Okay.
what we want.
Now we wanted to take something like let's go south
Several times.
several times.
It's basically we want
So-
to
so
replace,
far, yes.
replace this with something we
Yes.
used here, right? So that's the current position, and then south.
Because
Lowercase, yeah. Player at
Position
it
8.
equals to the player. Yeah, of course. Yeah. And then we can count, and then we can replace the return with that thing. Should be count. Oh no, it has to be if again. No, I think what it was. Sorry, I'll undo. It was this condition that we replaced.
Yeah, sorry.
If yeah, if is the winner. Winner, then we do player, and this will be is the winner. Something like that.
Okay.
Right.
You can remove that.
Yeah, this is
yes.
just some code. It's not the nicest thing. While it's not equals null and that type of thing. And is the winner now int? Yeah, of course, it has to be like greater than equals to 4.
Oh, yeah.
And finally, we get to this thing. So So,
Okay,
yeah.
okay, that's a note, and the previous one is no winner.
Yeah, so we kind of refactored this.
Yes.
To,
But
it takes some effort. Not sure. That was
the next thing is that at this point we only need to generalize this list.
Yeah.
Could be, I suppose it must be a function.
Oh,
It
a
cannot
function. Oh, yeah, see, it's like a function which keeps applying another function which goes south, something like that.
Yeah, this will be like vertical. Or will it be south? Go south. Let's call it go south.
Yeah, sure. I thought it could be even more generic. Just basically try and apply this south function 4 times.
Yes.
Maybe later.
Yeah.
Let's just,
No. Exactly. That's why I want to
later
go
on.
basically.
Yeah.
So yeah. So we have a go south 4 times.
Yeah, that's already nice.
Yes. And then we can also say that this south is
It's a parameter.
yes, and the parameter. So this will be. I want to basically say something like go south equal go
and colon south.
yeah position and then position.
Yeah.
So.
Yeah, it should. Yeah, I see what you mean. Should still work.
And then
Yeah, this becomes private.
there's no way we define everything as private.
I
There's
think
no-
it's doable. What you typed, I think it totally can be done.
position
Then
and
we just want an extension with just basically some function f. Let's
well,
say,
this
like-
will be a something that from a position return another position.
Yeah,
suppose.
position question mark. Like right now, that's what we have.
Position
And
question
it should
mark.
be f.
This is the type, but the
Yeah,
let's call F.
Yeah.
Or
that looks fine. And then it also returns a list of.
return a wisdom, but
Yeah, all I was trying to say is just the return type has to be list of
okay.
position question mark. That's the thing. And then we apply it here. Should just work f. Basically that.
Okay.
And list of maybe yeah, okay, this will do, right?
Yeah. Well,
Yeah.
you want to?
I was
I mean,
just-
we can also use a for, but
I also wanted to do like take while. Well, let's do this first. That's the
Yes.
refactoring, right?
Yeah.
Hopefully it's all good. Yeah, this looks
Okay.
fine. It
Yes.
runs. Then one more cleanup. I want to like just get rid of nullables in list. Take while it's not null. It's not equals null.
I wonder if you can
Maybe.
put a filter not null there.
I was thinking about it just to enforce invariance. Okay, so this
Yeah.
is fine. That was the cleanup. But now we have more generic functions. So it's not goes. Oh, it is goes out now.
Yeah, it goes out
Could
there.
we just inline this? I think
Well, I was thinking.
it's go position. So that, I mean,
Okay. Yeah.
that's kind of looks almost the same.
Yeah.
It's quite short. And yeah. Okay, I'm happy with this. And then we have few of those checks. We also need to check in other directions.
Yes.
But it should be easy to do now.
Yes. And then
So if you, I don't know if you want to type.
because at this point this is check winner vertical, but we can actually say check winner.
Yeah. It is. Yeah, you could.
This is actually the vertical winner.
Yes. Yeah.
Okay, let's say
Just vertical. Yeah. Well, yeah. That makes.
Yeah. And we can also do something like
Horizontal.
yes.
It should be
example.
straightforward to do horizontal. Hopefully for a reason. Yeah.
Horizontal, that will be
Okay.
got on east, let's say.
Yeah. Then plus go west, and then we can. Oh well, we need to do take while.
Yeah, actually we can. Okay, we can also do.
Yeah.
Sorry, we can do this as a new function.
Oh, okay.
Extractor and say
Oh, I see. I see, I see what you mean.
count direction.
Well, that's the thing. Yeah. Yeah, I like that.
Private fun count direction, let's say.
direction,
Direction. And then this will be the same position, nf that is position that return position question mark, and then there is the player.
I think the reason I wanted it in the same function because lots of a bit of duplication, but it's fine. Then
Actually, to be honest, okay, I mean
it's good. Let's go this way.
This is a pure function. We can put also player as I mean it's a field of the board, so we can actually. But anyway.
No. Let's just go down this route.
Yes.
Let's see what happens.
And this will be basically go with position f.
And then we do take while and count.
Yeah, it's still in the.
Yeah, that should do.
Yeah. Oh.
Good at this.
So this will be not go, but will be count the direction.
Yeah.
With the player. Okay. And then this point we can say also horizontal is count the direction position. Maybe there is a better way, but position east. Player, but then we need
the sum.
Yeah, because you need the sum with the west.
Yeah.
West, and I also suppose that we are actually counting
the same player twice, so
yes.
-1.
Yeah, but okay, we can say that must be bigger than 5.
Yeah. Well, I think I'd rather do -1 because then it will be kind of.
Yeah. Okay.
Maybe,
Yes. So it must be.
I would keep 4 just to say that the right half of the condition is the same, but on the left we do -1 because of double count of the current.
Okay.
That's the reason I would do it this way. I guess we could.
You can put -1 directly in the counter direction, or.
But in this case, we want to count this. Then we'll need +1 here. So we have this option.
Yes.
We do
you're right. Yes, because
I would just run this. It's still. Oh yeah, of course we didn't do east. It should be straightforward.
Yeah.
So do east. Well, straightforward in the sense that east and west. That's all what we want. So we don't check for rows anymore, right?
Yeah, no. East and west, we only check
we
for
know that the row
column.
is correct. And column is also guaranteed to be correct.
Yeah, but if it's a column 1, column A, then it will be...
Yeah. So if column equals column A, then there is no east.
Yeah.
Oops. Yeah, column A basically. Otherwise we do that thing.
Column.
But it's column. And again, I'll do just column.
Columns values.
Yeah, there is a way to do it with more reflection, I think, but we're not doing it right now.
Yeah.
East -1 will be and then west.
No, east is +1.
Depends on how we want. Oh yes, of course. Yeah, sorry, that's basically right. Yes.
Yeah, I mean.
Thank you.
That's why we needed to pair because.
And column.
G is the last one.
Yeah.
Yes.
That's the interesting thing. Then it should also probably have a variable last column instead of just G. That's that's another refactoring we could do. So that's -1 then.
Yes.
Okay, I'll run it. Whoa, that becomes exciting. Fails.
There is no winner.
It's blowing up on west.
Okay, So.
Oh, it's the other way around, right? This is A, this is G. That's why. If we
Yes, of
this
course.
was because I got confused initially.
Yes.
So this still works, that's good,
Yeah.
but we never really plugged in vertical, thin, and horizontal, so I think that we do clean up. So this is...
Yeah, we also needed to...
And then if vertical or horizontal,
Yes.
then the play. We don't really check for horizontal at all. But
Okay, we can check, we can...
change the...
Yes.
Yeah. Yeah,
This
like
is
a
a bit,
kind of
okay.
thing.
So this is how, if we remove a bit of this stuff, and instead if we go, what is D&D? Let's try to run this.
D&D. Yeah, I guess if you go like A, B, C for the same player, and left and right column is player.
Yeah, how it is right to run.
Column. Oh, run shift F10. Oh yeah. Wow. Wow. Okay, you're right. That
Okay.
works. Apparently.
So okay, yeah. So
Yeah,
that's
that's pretty.
and
cool.
the previous one was still
Yeah.
no winner.
Yeah.
Cause, yes.
Yeah. So it looks correct. Wow. Cool.
Yeah.
Just thinking, should we wrap up here because
Yes.
other directions should be like combination of those pretty much.
Yes, I think it should be kind of mechanical to finish
Yeah.
the other direction and the cleanup.
Yeah, I definitely need some clean up, maybe some approval tests.
But it was nice.
Yeah, it was quite
It came
interesting.
out quite well.
Yeah. Cool.
And you will put on GitHub. So
Yeah. I guess I was a bit skeptical initially about using enums for rows and columns.
Yeah.
But then the interesting side effect I noticed then when we were doing move east and west that just like, oh, actually it's impossible to get the wrong column here. That was a nice proof. Yeah.
Yes, it's well. I suppose this value of stuff is not perfect. I mean,
It looks a bit.
yeah,
But
we can also do something better. It's a pity that Kotlin does. Some language have enum next or private stuff like that.
yeah. I
But
suppose you could define those.
yeah, you
tags
can
and your
define
some-
as an extension.
So your
function.
own library somewhere.
Yeah, but definitely, this is really nice. Well, maybe in the future we can do the solver. But,
Yeah.
yeah. Thank you very much,
Thank you.
Dimitri.
Yeah, thanks.
This has been really a lot of fun.
Bye.
Bye.